Alright, so year 9. So this will be our first lesson for direct proportion. Okay, so there are two parts of this video. The first part is about a little bit review on rates and proportion, and the second part we're going to do some calculation on direct proportion. So let's first introduce what's the direct proportion. But before we understand what's direct proportion, you need to review some ideas about rates and ratio. Okay? So just make sure you know that rate and ratio are two different concepts. Okay? Although both involve division between two numbers. Okay, but they're different. The rate is about the comparison of two different quantities. Okay, so it's the division between two different quantities. Alright? And ratio is the comparison or the division of the two quantities of the same type. So we are going to define what do we mean by same type. Okay? And how could we identify whether a comparison of two numbers is a rate or ratio? So the simplest thing is to see whether they have units. Okay, rates normally can be identified by the units specified. Okay, for example, if you see something like kilometer per hour, that's what we call speed of the car, for example. And km per hour, kilometer is units for distance, and hours unit for time. So normally we rate it as kilometers per hour. Okay, right? So when you have a number called 60 kilometer per hour, so you see they involve two quantities, and with two different types of units. They got distance with units kilometer and time with units hour. So there are two different units. So for this type of numbers, you call them a rate. Okay, but for ratio, because they are of the same type, for example, when you have a recipe, normally you would talk about what's the ratio between the water and flour or cordial, something like that. Alright, so when you talk about, for example, the volume of water and cordial, they both are volumes, and so they have the same kind of units. So they will have milliliter, ml, right? Okay, so if both have a milliliter, so when you divide them, the final number won't have a unit. So ratio will express without units. Okay, so that would be the simplest way to see whether a comparison of two quantities is rate or ratio by just looking at if they have certain units. If they don't, it's ratio. If they have, they are rate. All right. So the first question we're going to see is identify whether each of which sorry, it's a bit messy here. Each of which I think each of following is a rate or a ratio. Okay, so you need to identify whether it's a rate or a ratio. All right. Okay. So how about the price of milk? So for the price of milk, it involves two quantities. Involves the money is dollar sign, and also the unit of volume. So there are two different types of units. You got money and also you got liter. So normally rated as $1 per liter. Okay, so of course this is a rate. Okay, because you see the units. Speed of the car, kilometer per speed should be hour, right? So let me change it. kilometer per hour. Okay, so it's like a distance and time. All right, so it's distance versus time. So again, because the number got two different units together, so it's a rate again. Number of students to number of teachers in a school. All right, so of course we know that in a school normally number of students will be much greater than number of teachers, but that's what we call a students to teachers ratio. Okay, so in this school there are 15 to 1, so that means for each teachers there are 15 students, so the ratio is 15 to 1. Okay, so do you see any units here? No, because we understand both number of students and number of teachers, they have the same type. They are same types, right? So they are both are number of things. All right. Okay, so it's 15 to 1. All right. So that's one way to write ratio. You just write 15 and heaven and 1. Okay, so that's one way to express it. So it's a ratio. Okay. Okay, so portion of butter to flour. Okay, portion means you understand that it's like part of how much part of something, right? So butter to flour is 1. So that's another way to write the ratio 1 to 20. Okay, so both butter and flour, possibly you could use the mass gram or volume liter. All right. Okay, so since there's no unit, it's a ratio, right? Scale of map. Normally we understand that in the map all the things is in a scale, all right? So you need to magnify that scale to get the real size of the object. All right, so normally in the map, so that's 1 to 1 over 10,000. That means 1 to 10,000. That means on the map, 1 cm will be 10,000 cm. Okay, in the real world, all right. So that's ratio because you don't see any units here, and also it's kind of length to length. They're of the same type. Okay, growth factor of COVID-19 virus in the US. Okay, so let's see. The number is 1,200 cases per day. Okay, so per day, day is a time, is a one sort of a unit. Number of cases is a number, right? So that means each day there will be 1,200 cases in the US for COVID-19, right? So that's not a very good number, but it's what happens, right? Okay, so how about this one? Rate or ratio. You see the units. Day is time. Cases is number. So it should be rate. All right. Okay, so that's how could we identify rate and ratio. Okay. All right. So sometimes you might be asked to find the units, find the proper units for different rates. You are not going to ask to find the units for ratio because there will be no units for ratio. Okay. Okay, can you match the following? Can you match the following to their rates? Okay, so fuel efficiency of a car. Okay, so fuel efficiency. Efficiency means how efficient that you could use the car to consume the fuel. So normally we know when you talk about fuel, it should be have units of volume. So where do you see the unit volume? Of course here, liter. Liter means a volume, or units for volume. Okay, so km means distance. So if you use this one, that means each liter can travel how many kilometers. So of course this is a rate, and this is a good rate for proper rate for describe that fuel efficiency, isn't it? So it should be 8 for kilometer per liter. Rainfall, so possibly when you watch TV for weather forecast, normally you know that when we describe the rainfall we use millimeters, right? So, and also we are talking about daily rainfall. Okay, so it should be millimeter per day. So it's a rate, and it should be used to describe the daily rainfall. Okay, and speed of the car. Normally we have done this a few times. Speed means distance versus time. So you are going to see kilometer per hour. All right. So the last one, price, of course, it involves dollar sign. And when we buy fruit, sometimes you buy against the mass of the fruit, right? So it should be D. All right. So that's how we see we match different rates to the units. All right. So simply put, you could say rate is more complicated. It's more informative than ratio. The ratio, we don't have units. Okay, so let's talk about our main content, our news knowledge you need to grab this lesson. It's about direct proportion. Okay, so direct proportion could be rate or ratio. All right, it could be a rate or a ratio. Okay. So, but why do we need to use that term? Okay, so it's because sometimes you involve two quantities which can be changing. Okay, so that's what we call variable quantities. Okay, so if you got two quantities, one varies with the other. Okay, so these two variable quantities could have certain relationship. If you see one quantity increase, then the other increase at a constant pace, right, and constant proportion, then that's what we call direct proportion. Okay, so it's simply saying that it could be that rate or ratio, but you need to see that rate and ratio keep a constant relationship. One increase, the other increase by the same amount or by the same portion. All right. Okay, so let's do some examples. All right. Okay, so for direct proportion, that's one important thing to remember. So because it involves two quantities, for direct proportion, remember, if one variable or one quantity is zero, then the other must be zero as well. So 0, 0 must be included in that direct proportion. Okay. Alright, so let's have some very common examples. For example, price of milk. Okay, when we buy milk, it's about how much 1 liter, right? So if you are not going to buy anything, you are not going to buy any milk, then the price will be 0. So 0 liter of milk, then the price will be 0. Okay, so about if you want to buy 1 liter of milk, then the price is $2. Okay, I just make up the numbers randomly. Okay, right. So let's see. How about 2 liters, $4? Okay, the question is you need to identify each of which is a direct proportion or not. So you need to identify whether it's a direct proportion. Okay, so let's see. It includes 0, 0, right? Okay, let's see, 1 liter, then $2. Okay, so from these two numbers, what do we get? Okay, if you use $2 divided by 1 liter, that means $2 per liter, right? So for 1 liter, okay, that will give you $2. You spend $2. Okay, so how about when you buy 2 liter? You got $4, right? So let's see. Okay, so I'm going to use another color. So $4 divided by 2, then still $2 per liter. All right. So if both are two, so you see the division of two numbers. If you both use the amount of money divided by the volume, it gives you the same answer. So when you compare this one to this one, they are the same. Okay, then it satisfies our definition here When one increase, the other will increase at a constant proportion. Okay? And so, and the very short description will be, direct proportion can either be constant rate, constant ratio. Do you see a constant? Of course, this one should be rate because they got units. Do you see the rates are constant? Yes, because the rates are the same at two different situations, and also include 0, 0. Okay, so price of milk, how about that? Is it a direct proportion? Yes, it is a direct proportion. So that would be the answer. Okay, let's look at the second one. Okay, the second one is about price of chocolate. Okay, so another price. So 0, 0, of course, if you are not going to buy any chocolate bar, they are not going to charge you, right? So if you want buy one, it's $4. If you buy two, $6. Did you think this is a direct proportion? Okay, let's have a check. So if you got one bar, $4, how? If you divide them, then you will see. Okay, so let me get another color. Sorry. Let's be a bit consistent on that. Okay, so that would do it like $4 per bar. Okay, but how about the second one? So if you do the second one, okay, use these two numbers. I use $6 divided by 2, and I got $3 per bar, right? Okay, so you see the two rates at two different situations. Okay, namely you buy one or two. So you buy one bar, each bar costs you $4. If you buy two bars, each bar costs you $3. So the prices for each bar are different in two different situations. So that actually happens in supermarkets. If you notice, sometimes you buy more, actually you reduce the cost for each item, right? Okay, so but in this case, are they still direct proportion? No, because you see the numbers, okay, the rates are different. Okay, so no, it is not a direct proportion. Okay, so you need to understand how to judge whether the two quantities are in direct proportion or not. So price of milk, okay, you could say the amount of milk and the price are in direct proportion, but okay, the number of chocolate bar and the prices are not in direct proportion. Okay, so let's see some ratio. Okay, so we know that's number of teachers and students in a state school. They are so-called ratio. They both are numbers. Okay, so let's see how could we compare ratios to see if they are direct proportion. Okay, for the first pair, just for the first pair. All right, so you see 300 and okay, so that 30 teachers, 300 students. Okay, so what's the ratio of that? Okay, so if you use number of students divided by number of teachers, then you will have 10. All right, and in the second case, okay, if you use 600, okay, 600 means 600 students, all right, divided by 600 students divided by 40 teachers, it becomes 15. Okay, so you see the ratio, they are different. Okay, if you want them to write into ratio, you can write 10 to 1 because that's the ratio, or you can write it as 15 to 1. But anyway, they are different, right? Okay, so the students to teachers ratio, okay, they are not constant, they are not the same. All right, so we say they're not a direct proportion. Let me just copy here, post it. Okay, it's not a direct proportion. Okay, right. So for the last one, okay, so it's about scale of a map. Okay, so length on the map is cm, real length is km. All right. Okay, so let's see. Right. So for the first one, 1 to 10. Okay, so how about the ratio? Okay, so if you compare them, it becomes, all right. Okay, so let me compare this as okay, so normally for map you can compare like 10 km, 1 cm. Okay, so if you want to convert units, that's up to you, but I think in this case I don't want to complicate things too much, so I just write 10 km to 1 cm. That will do it, right? Okay, so I'm not going to simplify it because this is not the purpose of this exercise. Right, so I'm going to do another comparison. So this time 15 km over 1 cm, right? Okay, so let's see the two same. Okay, so 1.5 cm. Okay, so actually if you notice, if you divide that's 15 by 1.5 becomes 10 km over 1 cm, right? So actually the both numbers are the same. Okay, so you could say they are in direct proportion. In direct proportion. All right. Okay, so let's have a quick look. Okay, so here we got two rates and two ratio. Okay, so we got two direct proportion and the other two is not in direct proportion. Okay, the key to see whether something is in direct proportion, you need to have a constant rate or constant ratio. That's it. So you need to know how to judge them. Okay, how to determine this relationship. All right. Okay, so let's go to example 4. Okay, so example 4 is about prices aren't always direct proportion to number of items. Which of these are in direct proportion? Okay, so this one will be just like the previous one, but the previous one we put numbers into tables, so it will be easier to you to compare. But this one is just a little bit tricky because the numbers are not in tables, so you need to read it harder, right? And let's do the first one. Okay, 1 A4 lecture pad costs $2.65. Okay, so and 10 A4 lecture pads costs $26.50. Okay, so you need to have, for all direct proportion, just like what we've done in previous tables, you need to have two quantities for comparison. All right, so here what are the two quantities? The first one is number of lecture pad. So when you circle them, okay, so 1 A4 lecture pad, so here 10 A4 lecture pad. Okay, so these two are number of lecture pad, and also there are lots of numbers but which are actually not relevant, like 140 pages. They are not relevant here because both packs are each pack of 140 pages. So I might just ignore them by moving them out. So give you a clear look what should happen here. So, and the other number you need to consider is the price, right? So this will be the price, okay, or the cost, okay, right? So let's see, and you need to pair them up. All right, so how could we pair them up? One Okay, one pack costs you $2.65, and 10 costs you 26. All right, so let's see, do they match? Okay, so let's see, do they match? Okay, so let's see the first pair. Okay, the first pair is, okay, so I use green color, right? 1, okay, versus okay, I got 10 here, and 2.65, 20. Okay, so here's the dollars. Okay, so do you see they pair up? Okay, so you might do the division for the first pair. So for the first pair here, you do like divided by 1. Okay, and for the second pair, you do like divided by 10. Are they the same? Okay, so see, this one's this one also this, so they are the same, right? Okay, so that means, okay, so this is a direct proportion. All right, okay, so you see this one's obviously more difficult than the last one, because last one actually I show you the relationship in terms of table, but this one you need to get the quantity out of the context. All right, okay, so let's do another one. Okay, an electronic game costs you that much, and 3 games. Okay, so this one possibly actually will be easier than the, so the first quantity is about number of electronic game. Okay, the second quantity is about the price again. All right, so let's pair them up. Okay, so you got 1, 1, and also you got 29.95, you got 89.600. Okay, so let's see if these two pairs actually are the same. Okay, the first pair just like, okay, 2 divided by 1. Okay, so that's our first pair. Okay, okay, so how about the second pair? So second pair, let's do this one. Okay, oh, sorry, I got something wrong, it should be 3, sorry. Okay, so it's 89.00 divided by 3, right? So let me check the number, but yes, according to my calculator, is again, okay, so 29.7. So when you look at these two numbers, are they the same? The first one should be 29.95, the second one 29.7. Okay, of course they are not the same. All right, so that's why this is not, okay, because they need to identify whether, okay, in direct proportion. So the second one is not in direct proportion. Okay, all right, so I'm going to let you to do the CDEF. All right, okay, it might take you some time if you want, if you try. Okay, okay, just pause the video to do them now. Okay, I'm going to show you the answer. Okay, so that will be the answer from me. Okay, you can track. Okay, so each time you just identify 2 different quantities, and each quantity have a pair of values. Okay, so there are 4 values. Okay, then you need to use one type of quantity divided by the other. Normally I would use the amount of money, the cost, divided by the other number, right? And you compare whether the 2 rates you got are the same. If they are the same, then they will be direct proportion, otherwise they are not. Right, that's it. Okay, all good. So all this about how to identify whether the pair of quantities could be direct proportion. All right, okay, so let's assume, okay, for the following question we will assume that direct proportion exists, but we are going to tell you how to use double line method to find, so given one quantity, can you find the other quantity? All right, Okay, first you need to have two types of quantities. Okay, so read the question. You are paid $20 per hour. Okay, do you see that there are two quantities? Okay, $20. Okay, I use one, possibly use this color. And how about the other? Hour. Okay, so there are two quantities. Okay, so identify. So first step is always try to identify. Step one. The first step, very important, is identify two types of quantities. Okay. Okay, so in this case, you need to interpret that. So that's the pay, right? You could say, okay, so this is the money, which is the paid, all right? And the other would be just the time. Okay, right? So, and the information here, 20 hours per hour, $20 per hour. That means in each hour you are going to be paid by $20. Okay, so that will give you the first pair of first pair of values for the two quantities, right? So, and then you are going to find 2 hours. How much are you going to be paid? So each hour you are going to be paid $20. How about 2 hours? So if you are quick enough, you know that should be 40, right? But what do we mean by double line method? So in a double line method, you will write your answer like this. So first, you need to identify the two quantities. That's money, that's the paid, and the time, okay? As two columns, right? And then you write the money, the pair of values. You know that's the first pair, which is given by the question. So this pair is, okay, is given by the question. So it's already known. Okay. So it's already known. Okay. Then you are going to find another pair. So they give you 2 hours. Okay. So here is the 2 hours. So it's given as 2 hours. And then you are going to find the pay. So okay. So let me delete this. So here will be the values you are going to find. Okay, so the whole setting is like, okay, if 1 hour you are going to be paid $20, so the time is in hour, we know. If in 1 hour you're going to be paid by $20, how about 2 hours? How much are you going to be paid? Right? So the double line method is like this. From 1 hour to 2 hours, you times 2, right? You see, we write times 2 here. Alright? Okay, so if the time times 2, because it is direct proportion, we know the other quantity must be increased by the same portion, by the same proportion, right? That's what we call direct proportion. So if the quantity of time is increased by 2 times, times 2, then the other quantity, which is the amount you are going to be paid, should also be times 2. So that make it 40 right here. So that's how we do it. Alright? Okay. Okay, so the second one is how about 5 hours and half an hour. So they are going to do the same. So every time it will be $20 to start with, $20 1 hour. So now you are going to find 5 hours how much is the pay. So again, this time this one's what you are going to be found. Okay, so what are you going to be found? Alright. So 1 times 5, you got 5 hours. 20 times 5, 100. Just the same. Okay. Oh, good. So let's have a look. So possibly it would be easier for me to start with new question, so you will see the whole picture. How could we do it? Okay, so let's do one new question over here. The speed of the car is 60 km per hour. How far can it travel in 4 hours? Okay, so we understand each hour it travel 80 kilometer. But first, you need to identify two quantities. Okay, so the first quantity is 80 hour, and the second quantity will be 80 km is the first quantity. The second quantity will be hour. Okay, so let's identify them. So the first quantity, that's km, means the distance. All right, so distance. Okay, and the second quantity, which is what we call is hour for units, that means time. Okay, so let's try to do it now. Okay, so let's do it by double line method. So let's write that distance on one side, and so distance km, and let's write time, which is hour, on the other side. Okay, so from the question, 80 km per hour, so that means in 1 hour you travel 80 kilometers. All right, so how far can you travel in 4 hours? So given 4, okay, so you need to find how far, so that means you need to find distance, right? So okay, so that's a box you are going to find. Okay, but how can we find it? Okay, just consider from the perspective of time, from 1 hour to 4 hours, how much it being increased 4 times, in time times 4. Okay, so if this side is times 4, the other side must times 4 as well. Must times 4 as well, right? Okay, so that means I'm going to do this part. All right, so that means this numbers will be 320. Okay, so that's how you answer the first question. Okay, so first question, how far we can travel 320 km. Okay, so that will be easier for you, right? Okay, so let's go for another one. So another one, I'm going to use the same setting. How long? So for B, it's how long, it's not how far will you take to travel. That means you need to find the time. All right. Okay. So let's copy this. Okay. So I'm just lazy. Right? Okay. So again, we start with 1 hour 80 km. But this time, you are going to travel 400 km. So let me write 400 here. Okay, then you are going to find the time. So time is over here. So that's what you are going to find. That's what you are going to find. Okay, so this time we give the left hand side. Okay, how many times from 80 to 400, right? So you must times what number? Okay, so if you can't do it by heart, you can always do it by like 400 divided by 80, which should be 5. So you need to times 5 times to get it to 400, right? Okay, so on this side, you are going to times 5 as well. So it should be 5 hours, okay? So the answer, it takes 5 hours. All right. Okay, not much room for this one. Okay, so need to create some space. All right. Okay, so let's do the second one. Okay, so question 7. A car uses 4 liters of petrol in 50 km. Okay, so you see two quantities. So that's one quantity. So this is what we call volume of petrol. So the other quantities will be 50 km, which is distance travel. Right? Okay, let's do it. Okay, so let's see. this time I got volume. Okay, I'm going to write smaller because I'm running out of space. Volume and distance. Okay, so I got volume, which is liter, that's km, right? So I got 4 liter travel for 50 km. How much will you use in 125 kilometer? Okay, so this is what you are looking for. All right, so how many volume? Okay, so how much petrol are you going to use? Okay, think of 50 times watt equals 125. It's a bit difficult to think it like to use mental math. So possibly you would just use 125 divided by 50 to find the factor you need, right? So that will be okay, that would be 2.5. Okay, so this time, this side you have to times the same factor, 2.5, that would be 10, right? Okay, so the answer will be use 10 liters. Okay, so that's first part. Okay, let's do B. So part B is about how far, that means kilometer, right? Okay, so again, you write the same thing over here, right? Okay, so then we are going to do 450. So everything will be the same to start with, but this time they give you the volume of petrol, and you are going to find the distance, right? Okay, so let's see. From 4 to 15, what's the factor? Okay, so it's quite difficult, isn't it? So you actually times 15 divided by 4. So that would be 3.75 as a factor. So on this side, you times the same factor. And right, so let's see if that's even correct. Yeah, so it would be 187.5. Okay, so the answer, it can travel 180.5 km. Alright, so try to understand this, make sense of it. So I've done 2 questions in very similar fashion. Alright, okay, each time you just need to identify 2 quantities, write them into 2 columns, and you got the first line from the given conditions. Alright, then you think of the factor you need to move to the next line. Alright, okay. So, okay, for question 8, so it's about a question of ratio. So because you see 2 buckets of sand and 3 buckets of blue metal, so both are about the buckets. So they are pretty much like okay, so they're pretty much like question about ratio, because both are about the volume. Alright, okay, so the 2 quantities again is sand, and the other quantities will be blue metal. So both are in buckets. So let me see. Okay. Right, so let's do it this way. Okay, again I'm going to make columns. Alright. Okay, so I got sand over here, and the other is blue metal, BM. Right, both are in buckets. Alright, okay, so let's write for 2 buckets of sand, 3 buckets of blue metal, so 2, 3. How much blue metal is needed for 15 buckets of sand? Okay, it's here. So that's what you're going to find. Okay, good. And think about the factor here times what. Okay, so I'm running out of space again. So this one times 15 over 2, 7.5 times. Okay, that means here you must times 7.5. Okay, so this will give you 22.5. Okay, so the answer is needs 22.5 bucket of blue metal. Alright. Okay, so I'm going to give you time. Try to do the second one to make sure you understand. Okay, so again, you are going to write the same thing as I've done before. Okay, alright. Sorry for my handwriting. 2 and 3. Okay, so can you do B by yourself? Okay, can you do B? Do it now. Okay, I'm going to pause the video now and try. So that will be the answer, right? If you got it right, so you're on the right track. If you got something wrong, just make sure you understand which part is wrong. Alright, okay. Alright, so if you got no problem for this one, okay. So let's see the question 9. Okay, it's about potatoes. About 9. So you got $9 and 2 kilograms. So again, you need to identify two quantities. One should be the cost, the other should be the mass or the weight of the potatoes. Okay, and A, how much would you pay for 8 kilograms? So basically, you know the mass, you need to find the cost, alright? Okay, so I'm going to give you the time. You need to try that A by yourself. Okay, if you got A correct, then we move on to B, and you need to try that by yourself as well, right? Okay, so pause the video, try to do 9A. Okay, so that will be the answer for A. Anything correct? So that two quantities should be the cost, and cost is one quantity, and the mass and the weight, actually we could call weight or mass. Okay, the weight is another quantity. So you got cost $9 and weight 2 kilograms. So another situation is that if you are going to buy 8 kilograms, how much are you going to pay? So you need to compare the two sets of values, right? From 2 to 8, you multiply by 4. And then on the other hand, 9 times 4 as well. So you need to times the same factor for 9. You got it to 36. Alright, so if you are ready, then pause the video, try part B as well. Okay, so the number you are going to multiply, be careful. Okay, the number you are going to multiply will be 5 over 9, not 9 over 5. Okay, alright, so always use your target number, which is 5, divided by the number you begin with, which is 9. So, and you try to see if 9 times 5 over 9 is 5, right? So, and that number actually is a recurring decimal. It should be 0.5555 like this. So, and you, on the other hand, you have to multiply the same thing, and if you run off, the answer is to be 1.11 kilogram. All right? Okay. Okay, so we are going to try one more. Okay, so this time 2 liters of paint cover 35 meter square area of wall. Okay, so can you do this one? I'm going to give you time. You try yourself or do this one, and also the next one as well. Okay, so question 10 is a rate problem. Question 11 is a ratio, because both are about mass. All right, the grains are about the mass, right? Okay, so, and question 10 is a rate. All right, okay, so give you some time to do it. Okay, so for question 10, you see there are two quantities. One is the volume, the other is the area. Okay, so you see, and that 2 liters for 35 meter square area. Okay, then you need to find the factor, which is from 35 to 64. So you times 64 over 35. All right. So that factor, the factor is not that nice. is 1.829, but you still need to use it for the other side. Okay, so A is pretty much is quite nasty, but B is much better, because from 2 to 8 times 4, and 35 to times 4, 140, right? And for question 11 is question about ratio for direct proportion. So got butter mixed with flour. So 100 gram of butter becomes and 150 gram of flour. And then if you want to make a larger cake, then you need to have more butter, but you need to have more flour as well, right? So part B is about making a smaller cake, then you need less flour. So again, both part A, part B is to find the amount of flour you need. So okay, just so do what I show you, that will do it. Okay, so the last thing is about the currency. Okay, so the currency actually could be quite tricky. Yeah, so currency means you convert Australian dollars to other currency, to other money, other type of money, so you could go to travel, right? So for example, right now, 1 Australian dollars could exchange 60 cents of US dollars. Okay, so actually this is what we call a ratio, because both are money, right? But all exchange rates should be in direct proportion, all right? And so so how could we change how much US dollars worth like 100 Australian dollars? Okay, again, you see that two types is quite obvious. You got Australian dollars, and that's one type, and you got US dollars, that's another one, all right? And all you need to do is just like do the things we have been doing. Okay, it's like, all right, so let's write the thing like this. Okay, you got Australian dollars, you got US dollars. Okay, so for Australian dollar, you got $1, 60 cents. You got 100 Australian dollars. Okay, how much do you get in US dollars? So you see, it's not that difficult. 1 to 100, of course, you times 100. Times 100 as well. Okay, so you got 60. Okay, so for part, so that's part A, right? For part A, okay, it worth like 60 US dollars, $60. Okay, how about 100 US dollars? How much Australian dollar can you get? Alright, so again, you just write all the thing like before. $1 here, 60 cents here, but now it's 100 US dollars. Okay, you need to find the numbers here. Okay, alright, so this part possibly a bit difficult. So think, what number do you multiply from that 0.6 to 100? Okay, so you could always multiply. So the target number is 100. The number you start with is 0.6. So if you multiply 100 divided by 0.6, whatever number it is, you will get your 100, right? Okay, so let's see, what number do you get? 100 divided by, okay. So it will give you 161667. Okay, so we just multiply 16667. Okay, so that make it 16667. Alright. Okay, so it worth Australian dollar 16667. Okay, that's it. Alright, okay. So this is a pretty long video, and we have some exercise for you to do. It includes how to determine whether a direct proportion exists or not. It also involves how to use double number line, so the skill we're using here, right? And also some understanding about the definition, race, ratio, and direct proportion. Okay, there are only 3 questions. Okay, you could try to do them and send email to me. All right. Okay, so that's the end of this lesson. See you next time.